Welcome to another episode of Old Guy Physics, and today's lesson is going to be on objects sitting on an inclined plane. This is the next progression in many of the different forces that we have learned. And so I've drawn a picture here already of a box sitting on an inclined plane, and it says that the box is a 4 kilogram box. And it shows here that the coefficient of friction on the inclined plane is 0.20. So in step number 1, I said in class, let's try to establish what each of the forces are that are acting on the object that's on the inclined plane. Okay? And I suggested that you draw those 5 arrows every single time. Now, those 5 arrows represent the forces that are going to act on the object. First of all, if it's a 4 kilogram object, then automatically this is F of G, and that's going to be 40 newtons, because F of G is the weight of the object. And, hold on a sec. We did not establish this yet, but let's go ahead and plug this in right quick. Let's make this a 35-degree angle. Okay, and so the second part of that is to figure out what is F of X, which is this one here, and what is F of Y, which is this one here, which is down the inclined plane. One's perpendicular, the other one is parallel. Okay, and so in class we've been running this polar rectangular. You can also solve for F of X by using the cosine, and you can solve for F of Y using the sine. But let's run this right quick. Polar to rectangular looks like this, just to refresh your memory. The polar coordinates are going to be r comma theta, and the rectangular coordinates are going to be x comma y. And so our polar coordinates are going to be that it's a 40 Newton object at a 35-degree angle. Those are our polar coordinates. When we plug those in the calculator, it should give us our x's and our y's. So let me run that right quick. We got 40 and a 35, and our x is going to be 32.77. I'm going to round that to 2 decimal places, and that's newtons. And the F of Y is going to be 22.94 newtons. Okay, now, you should remember from class that the normal force is the force that is the supporting force supplied by the inclined plane. And it is going to be equal to, but opposite, F of X. Now, you should remember on a table where it's a flat table, the normal force is equal to the F of G. But when we're on an incline, only that part which is perpendicular to the surface will be the normal force. And so F of N will be equal to F of X. So we've got that equal to 32.77. That's important because when we go to solve for the force of friction, again, we said the force of friction is that force which tries to prevent the motion. And so if it's going to slide down the inclined plane, the friction is going to be the force that tries to prevent it. And we need that frictional force to solve for the net force. So let's solve for the force of friction right quick. Remember, the force of friction is equal to the coefficient of friction times the normal force. Coefficient of friction is right here, 0.20. And the normal force is 32.77, like that. So 32.77 times 0.2 is 6.55. So 6.55 newtons is the normal force, or excuse me, is the frictional force. Now, to solve for the net force in this problem will be equal to F of Y minus the force of friction. because these are the two forces that are acting in the direction of the motion. And so we have 22.94 minus 6.55 is 16.39. 16.39. And that's also going to be equal to the net force, which says that that's equal to M times A. And so we plug the mass back into this equation where it's a 4 kilogram object, and 16.39 divided by 4 is 4.10. So the acceleration is 4.10, and that's meters per second squared. And so all of that information right there would be the way that we would try to accomplish one of these problems on the future test coming up. Now, if you have any questions about any part of that, you make sure that you, after you watch the video, you come back to class and you ask good questions, and we'll see if we can't get you squared away on how to work problems where the object's sitting on an inclined plane. Thanks for watching. Have a blessed day.